In this video, we're going to talk about the different ways we can classify matter. I'm going to make this flowchart on my sheet of paper right here in this video, and so I suggest that y'all take out a notebook, sheet of paper, and follow along with me. And so when we classify matter, there are two main categories we can split them up into. We can split them up into pure substances or mixtures. Within those categories, we can further split them up into two more categories. So we can get pure substances and further split it up into elements and compounds, and we can get mixtures and further split those up into two categories, homogeneous and heterogeneous. And so we're going to take a closer look at pure substances first. When we look at a pure substance, I want us to remember that pure substances are it's matter that can't be separated by physical means. And so when we look specifically at an element is a substance that also can't be chemically separated. And so anything on the periodic table is considered an element. And so an example would be something like carbon. The symbol for that is AC. It can also include your diatomic elements or your diatomic molecules. And so an example of a diatomic element would be something like hydrogen. And so remember, diatomic, when we write those down, it's going to be two of those atoms bonded together. And so that would be something like H2. And just as a reminder, there are 7 different diatomic elements that we have memorized. And then I guess something like sodium would also be an example of an element. So again, anything that's on the periodic table of elements can be classified as an element. Aside from examples of elements, you also need to know what they look like if we were to draw them as a particle diagram. So I'm going to go ahead and draw 2 boxes here so you can see what that's supposed to look like. And so if I wanted to draw an example of carbon, for example, so I'm going to put C for carbon. When we draw a particle diagram of elements, the key thing you should notice is that it's the same image repeated over and over and over. And so if we have something like carbon, I'm going to say carbon, these dark circles represent carbon. And so in a particle diagram, all I should see are the same circles repeated over and over and over. If I was drawing something like a diatomic element, so something like hydrogen, so H2, and I said white circles were hydrogen, we have H, and there's 2 of them, so we got to make sure that there's 2 of them chunked together. And so again, when you're looking at the particle diagram for something like a diatomic element, you should have 2 of those same elements, so in this case 2 hydrogens chunked together, then also that same image repeated over and over and over again. So something like this. All right. Again, when we look at pure substances, another category of pure substances we can look at are compounds. And so compounds can be chemically separated. So an example of a compound would be something like table salt. And so table salt is NaCl, so this is the salt that you have probably in your cabinet somewhere at home. Another example would be something like water, so H2O. And then even something like carbon dioxide. So that's CO2. And so as a reminder, compounds are whenever we have 2 or more elements chemically combined. So when we're drawing a particle diagram, I'm going to draw 2 examples for you. So I'll draw 2 boxes right here. If I'm drawing something like NaCl, so our table salt, if we said Na is a white circle, Cl is a dark circle, so that's like our key right there. The point here is when we're drawing a particle diagram for a compound, again, you draw the compound, and then you're going to just draw the same thing over and over and over again. So just like this. So in your particle diagram, it should just be the same image repeated over and over again. So same thing if I was drawing something like water, so H2O, and you can see that in both of these you have two or more elements, two or more different elements. H2O, if I made this my key, so they look like little Mickey Mouse ears here. When I draw in my particle diagram here, it's just the same image, again, repeated over and over and over again. So elements and compounds are just a category of pure substances. So what we're going to do is we're going to now move on to mixtures. And so when we classify matter, we classify them as mixtures. Mixtures can further classify into more categories. You have homogeneous mixtures and heterogeneous mixtures. When we talk about a mixture in general, mixtures whenever we have two or more different substances that you can separate physically. They can be mixtures of elements, they could be mixtures of compounds, or they could be mixtures of elements and compounds. So when we look at something like a homogeneous mixture, what makes it homogeneous, so the key thing is that it's uniform. So meaning it is evenly distributed throughout the mixture. So even though we have different things in the mixture, it's equally dispersed throughout that mixture. So some examples of a homogeneous mixture are like air, so the air we breathe. You have things like alloys, so this is a key vocab word that we expect y'all to know. So an alloy, just as a reminder, is basically a mixture of different metals. So something like stainless steel is composed of, I believe it's like iron, nickel, and a few other metals. And then another example would be something like salt water. So if we were to write that as a chemical equation, it would be NaCl plus H2O. And then another example of a homogeneous mixture is my favorite drink, sweet tea. And so the main thing you should be able to notice about homogeneous mixtures is that when we look at all these different things, if you had salt water in front of you, if you had an alloy in front of you, so something like a brass instrument, like I think it's the French horn, or even sweet tea, when we look at those things, when we look at those mixtures, they look uniform. It looks like it's just one thing. It looks like it's composed of one thing, but really it is a combination of multiple things. It's just distributed so evenly that it looks like one thing. And so another name for homogeneous mixtures, so I'm going to put AKA, so also known as, homogeneous mixtures are also known as solutions. And so we will go in more detail about solutions, but just know if I mention a solution, you should automatically think that these are homogeneous mixtures. If I'm drawing a particle diagram of these, because again, we want to be able to see what these look like if we were able to zoom in real close to these items. If I were doing something like an alloy, so I'll label this as alloy, and let's say this alloy is a mixture of something like nickel and iron. If we said nickel is circles, dark circles, and iron is triangles, again, in an alloy or any homogeneous mixture, everything's uniform, so it's spread out equally. So if I've got two circles on this side, we'll put two triangles on this side. And so if we were doing something like salt water, so NaCl and H2O, same concept. Again, it is uniform, it's evenly distributed. So if I made NaCl triangle square, and then these my Mickey Mouse ears, if I'm drawing here, if I have salt here, and then I also have water here, you can see that in this homogeneous mixture, it's evenly distributed and it's spread out equally. And when I like to think of homogeneous mixtures, if I'm thinking of something like sweet tea, I know it's evenly distributed, assuming you make it right. I know it's evenly distributed because that first sip of sweet tea should taste like the last sip of sweet tea because the sugar and the water is all spread out equally throughout that sweet tea. So another type of mixture we're going to look at is a heterogeneous mixture. So the key thing about a heterogeneous mixture is these are not uniform. So they're not equally spread out. There is no pattern. You can see the different parts of these mixtures typically. And so examples of a heterogeneous mixture are things like trail mix. With trail mix, you can see the peanuts, you can see the chocolate, you can see, I like marshmallows in my trail mix. You can see the little chunks of marshmallows, but you can see all the different parts of it. And then when you're scooping up some trail mix, if I take a scoop of trail mix and I have a friend who also takes a scoop of trail mix, our mixture of trail mix is not going to be exactly the same. I might have more M&Ms, my friend might have more marshmallows. So you can see that there's no pattern, it's not uniform, it's different each time. Another example would be something like granite. And so what I'm writing on is kind of similar to granite. You can see, this chunk of my granite here is not the same as this chunk of the granite. You can see that there's different colors, different things in that mixture. And then another example would be something like salad. So again, with these mixtures, so when you're comparing hetero to homogeneous, you can see that when we look at things like trail mix, granite, or salad, you can actually see the different parts. You can see it doesn't look like it's just one thing. It's a combination of different things and not necessarily, it's not a uniform mixture of it. So if I'm drawing a particle diagram, I'll draw, I guess, two as an example. When we're drawing a particle diagram, if I wanted to draw like a salad, for instance, in our salad, we've got the lettuce, we've got tomatoes, you got cucumbers, if you like cucumbers, and then if you're like me, I probably have more croutons than I do actual vegetables, so you got croutons all over the place. Again, my first bite might have 3 croutons, my last bite might have no croutons. Because again, it's not a uniform mixture. It's not evenly distributed throughout the whole thing. And then again, basically with a heterogeneous mixture, there is no pattern. So if I've got 2 triangles and all these dots, and you know what, let's throw in a heart there because we can. Again, it's a mixture that's all over the place, and if I were to grab something out of this, there's not necessarily a pattern what I'm going to grab out of it. So essentially what we need to be able to do is we need to be able to classify matter in these 4 main categories. You've got elements, compounds, homogeneous mixtures, heterogeneous mixtures. And so when I'm listing different things, I want to be able to identify a substance as one of these. If I'm looking at a particle diagram, I want to be able to look at that particle diagram and be able to identify whether it's a element, compound, homogeneous mixture, or heterogeneous mixture. And the other way around too, if I ask you to draw a compound or draw a particle diagram of a heterogeneous mixture, you are able to